Black holes are one of the strangest things in existence. They don't seem to make any sense at all. Where do they come from? And what happens if you fall into one? Stars are huge balls of mostly hydrogen gas that form when giant gas clouds collapse under their own gravity. At their center, hydrogen atoms combine to form helium, releasing a lot of energy. This energy, like a burst of light, pushes against gravity, keeping the star balanced and stable. As long as this process continues, the star stays happy and steady. But for stars much bigger than our Sun, things get more intense. The heat and pressure in their core let them create heavier elements, like carbon and oxygen, all the way up to iron. Here's the problem. Making iron doesn't produce any energy. It's like running out of fuel. Iron builds up in the core until the balance between energy and gravity breaks. In just a moment, the core collapses. The star caves in on itself, moving incredibly fast. This collapse creates all the heavier elements in the universe, like gold and silver, in a massive explosion called a supernova. If the star is big enough, what's left of the core shrinks into a black hole. Talk about a dramatic exit. If you looked at a black hole, what you'd really be seeing is the event horizon. Anything that crosses the event horizon needs to be traveling faster than the speed of light to escape. In other words, it's impossible. So we just see a black sphere reflecting nothing. But if the event horizon is the black part, what is the whole part of the black hole? The singularity. We're not sure what it is exactly. A singularity may be indefinitely dense, meaning all its mass is concentrated into a single point in space with no surface or volume, or something completely different. Right now, we just don't know. It's like a dividing by zero error. By the way, black holes do not suck things up like a vacuum cleaner. If we were to swap the Sun for an equally massive black hole, nothing much would change for Earth, except that we would freeze to death, of course. What would happen if you fell into a black hole? Time gets strange near one. From the outside, people watching you would see you slow down as you neared the event horizon. You'd almost seem to freeze, turning reddish before fading away. But for you, it'd feel normal. You'd see the universe speeding up, like watching a movie on fast forward. What happens next? We're not sure, but it's probably not great. Option 1. The black hole's gravity is so strong that it pulls harder on your feet than your head, stretching you until you're torn apart into tiny pieces. Ouch. Option 2. Just past the event horizon, you hit a firewall of energy that zaps you instantly. Either way, it's a quick end. How soon you would die depends on the mass of the black hole. A smaller black hole would kill you before you even enter its event horizon, while you probably could travel inside a supersized massive black hole for quite a while. As a rule of thumb, the further away from the singularity you are, the longer you live. Black holes come in different sizes. Stellar mass black holes are a few times heavier than our Sun, about as wide as a large asteroid. Supermassive black holes, found at the heart of galaxies, are much bigger and have been growing for billions of years. The largest one we know is enormous, stretching farther than the distance from our Sun to Pluto. Even black holes don't last forever. They slowly shrink through something called Hawking radiation. Empty space isn't really empty. It's full of tiny particles that pop in and out of existence. Near a black hole, one particle might get trapped inside while the other escapes, taking a bit of the black hole's energy with it. It's like a slow leak in a balloon. This process starts off super slow but speeds up as the black hole gets smaller. When it's the size of a big asteroid, it glows at room temperature. When it's as small as a mountain, it's as hot as the Sun. In its final moment, the black hole explodes with a huge burst of energy. But don't wait around to see it. The biggest black holes could take longer than the age of the universe to disappear completely. By then, the universe will be a very quiet place. This is not the end of our story. There are loads more interesting ideas about black holes. Like this video and let's aim for 50 likes and I'll make a part 2. Thanks for watching. You're awesome.